Hello and welcome to the AI Research Roundup. I am your host, Alex, and today is June 17th, 2025. We're looking at a brand new research paper from Google DeepMind, just published today, titled Gemini 2.5 Model Family Technical Report. This paper introduces a new family of models built as a sparse mixture of experts. Now, this architecture is like having a team of specialized subnetworks, and for any given task, the model only activates the most relevant ones, making it very efficient. They aim to advance reasoning, multimodality, and especially agentic capabilities, which is the model's ability to plan and execute complex, multi-step tasks. Alright, so to get a clearer picture of this new model family, the authors provide a helpful comparison table. It lines up the new Gemini 2.0 and 2.5 models against the previous 1.5 generation. What's immediately clear is the jump in capabilities. While all models can understand a massive 1 million tokens of text, image, video, and audio, the newer models introduce two key features. First is tool use, which is the ability to run code or search the web. And second is thinking, a new mechanism that lets the model use extra computation to reason through difficult problems. Building on those new capabilities, this next chart really visualizes the performance jump. It's a cost-performance plot. On the vertical axis, we have ARENA score, which is a rating from the LM Arena where humans rank model outputs, so a higher score is better. The horizontal axis shows price, with cheaper models over on the right. The new Gemini models trace out what's called the Pareto frontier, basically the best possible performance for a given cost. And you can see Gemini 2.5 Pro sits at the very top, outperforming all other models shown. Okay. So while Gemini 2.5 Pro is the most capable, it's not the fastest. This next bar chart shows us the generation speed, measured in output tokens per second, which is basically how quickly the model can write out its answer. And here, the new Flash models really shine. Gemini 2.5 Flash is at the very top, generating text at over 300 tokens per second. This really illustrates that Pareto frontier we just talked about. You have the highly capable Pro model for tough problems, and these incredibly fast Flash models for when you need a quick response. So, to really see the impact of that new thinking feature we touched on, these next charts are very revealing. We're looking at performance on three tough benchmarks here, one for math, one for general reasoning, and one for coding. In each case, you can see how accuracy improves. When you enable thinking for the Flash models, the scores jump up significantly. And then, Gemini 2.5 Pro, which uses what's called dynamic thinking, consistently scores the highest of all, really showing how this extra computation time translates directly into better reasoning ability. This table then gives us the full, detailed picture, breaking down performance across a huge range of capabilities, from coding and reasoning to math and long context understanding. The trend is crystal clear. Looking at the rightmost column for Gemini 2.5 Pro, you see massive jumps everywhere. For example, on the AME 2025 math benchmark, the score leaps from just 17.5% for the old Pro model to 88%. And on a tough coding test called SWE Bench Verified, which tests bug fixing ability, the score nearly doubles. These results really show a huge step change. And to put that huge step change into perspective, this table provides a direct, head-to-head comparison with other leading models. It lines up Gemini 2.5 Pro against competitors like Claude 4 and Grok 3 Beta across a wide range of tasks. And looking at the numbers, Gemini 2.5 Pro consistently scores at or near the top. For instance, on Aider Polyglot, a tough benchmark that tests coding ability across multiple programming languages, it scores over 82%. This kind of top-tier performance across so many different domains really solidifies its position as a new state-of-the-art model. Now, those last results were mostly focused on text and code, but a huge part of the Gemini story is its multimodal capability. This is the ability to understand different types of information, like video and audio, all at once. This table breaks that down, testing models on benchmarks with just video or audio and video together. And once again, looking at that Gemini 2.5 Pro column, it consistently leads the pack. On tests like Video MME and UCook2, it sets new state-of-the-art scores, cementing its strength beyond just text. So to really push those multimodal capabilities to the limit, the researchers built an AI agent to play the game Pokemon. An AI agent is a system that can perceive its environment, in this case, the game screen, and take actions to achieve a long-term goal. This chart shows the agent's progress over hundreds of hours. The final, fully autonomous run shows the agent successfully completing the entire game in just over 400 hours. This is a powerful demonstration of long-term planning, using a massive context of over 100,000 tokens to make decisions. Now, with all this incredible new capability, it's natural to ask about safety. This table shows results from what's called automated red teaming, which is essentially using one AI to automatically test another for safety issues. And the trend is really positive. You can see that as we go from the older Gemini 1.5 models to the new 2.5 Pro, the rate of both dangerous content and helpfulness violations drops significantly. For instance, dangerous content violations fall from over 43% to just 24%. This shows the models are becoming safer, even as they get more powerful. Building on that safety discussion, these charts look at another critical aspect, memorization. This is when a model, instead of generating novel text, just repeats snippets from its training data, which can be a major privacy concern. The chart on the left shows the new Gemini 2.5 models have a significantly lower overall memorization rate than prior versions. And more importantly, the chart on the right looks specifically at personal information. For the new models, the rate is 0. This result is a huge step forward for privacy and responsible AI development. So to formalize this safety evaluation, the researchers tested the model against the Frontier Safety Framework. This table summarizes those results. It looks at high-risk areas like cybersecurity and what's called CBRN, which stands for chemical, biological, radiological, and nuclear threats. The key concept here is critical capability levels, or CCLs. A critical capability level is a predefined threshold, where a model's abilities become potentially dangerous. And the main result here is clear. In every single category, Gemini 2.5 Pro did not reach any critical capability level. This is a very reassuring finding. Okay, so we've established the model is impressively safe. But what about its ability to perform complex, open-ended tasks? Well, this next chart looks at just that, using the Research Engineer benchmark. This tests the AI's ability to complete machine learning research tasks, things like optimizing code or fixing data embeddings. The scores are normalized, so a score around 1.0 means the AI matched a quality human solution. And what we see is really remarkable. In several cases, Gemini 2.5 Pro, the dark blue bar, actually surpasses expert human performance, showing it's becoming a powerful tool for scientific work itself. So, to wrap things up, the Gemini 2.5 family represents a huge leap forward. We've seen it achieve state-of-the-art results, while also being demonstrably safer and more private than older models. This is enabled by advanced architectures, like sparse mixture of experts, which help the model learn more efficiently and unlock powerful agentic capabilities. That is, the ability to perform complex, multi-step tasks on its own. The main takeaway is that as these AIs advance so quickly, the new challenge is actually creating tests hard enough to measure them. That's all for this week's AI Research Roundup. Thanks for tuning in.